Chapter 4, Pre-Algebra. Let's review. We started this chapter with the distributive property. So our instructions on these first four are to use the distributive property. So remember, the distributive property says that you have to multiply whatever is outside parentheses that have either addition or subtraction inside by all the terms, or in most of the cases just both the terms on the inside. So I do 6 times s, which is 6s. I just copy the plus sign they gave me. Do 6 times 10, which is 60. And we stop there because we cannot combine these because there are no like terms. Okay, same process on number 2. The 9 has to be multiplied by the a, which gives us 9a. We copy that minus sign down. 9 times 4 is 36. Three, we have negative 5 times 3 minus b. So we do negative 5 times 3, which is negative 15, because if the signs are different, one's negative and one's positive, the answer is negative. Then I copy this minus sign. Then negative 5 times b is negative 5b. Now, I don't plan to count off if you do leave the answer this way, but it's best to not leave two negatives in a row like that, minus a negative. It's best to go ahead and remember that minus a negative changes to plus a positive, and write your final answer as negative 15 plus 5b. Number 4, still doing the distributive property, 11 times m plus 7. So we do 11 times m, we just copy their plus sign, 11 times 7. Okay, number 5, suppose you pay $15 per hour to go horseback riding. So I'm just going to go ahead and write down 15 times h. I don't know that I have to do that, but I'm just trying to go ahead and work with what they gave me. $15 per hour. You ride 2 hours today and plan to ride 4 more hours this weekend. So A says write 2 different expressions to find the total cost of horseback riding. So you could say, okay, it's $15 per hour, and I plan to spend 2 hours today plus 4 more hours tomorrow to solve that. That's one way you could write it. Another way you could write it is, well, today I'm going to ride it for 2 hours, so today I'll be charged 15 times 2. Then tomorrow I'm planning to ride 4 hours, so I'll be charged 15 times 4. And the reason they want you to write it both ways is, if you notice, this is the same as the distributive property. 15 times 2 plus 15 times 4. Then it says find the total cost. So you can use either of these to solve that. You could say that's 15 times 6, which is 90. We could say 15 times 2 is 30. 15 times 4 is 60. And 30 plus 60 is 90. Sorry, I cut off there. But either way, the total cost, that's the answer to part B, is $90. Terrible arrows. Anywho. Okay, number 6, we're switching gears. So that was the distributive property we started with. Now we're focused on combining like terms. So the instructions say to simplify each expression. And what that means is combine like terms when possible. So in number 6, these are like terms. This is 1x. We just have a single x here, 1x, plus 3x gives us a total of 4x's. Okay, number 7, 10 plus 6x minus 11 plus 7x. So we got to see which ones are like terms. So 10 is a constant, has no variable with it, so is 11. And we always use the operation that's directly in front of the number. So this is 10 minus 11. 10 minus 11, if you want, you can do keep, change, change. And when you're adding numbers that have different signs, you subtract them. 11 minus 10 is 1. You keep the sign of the bigger number, which is a negative. So 10 minus 11, or 10 plus negative 11, is negative 1. Then these two are also like terms. It's a positive 6x plus 7x. So 6 plus 7 is 13x. So our final answer is negative 1 plus 13x. Now it would also be fine if you had 13x plus negative 1, or even minus 1. So the order you write the terms in doesn't matter, as long as you have the correct signs. Okay, now number 8 and 9, there's an important thing to remember, and that is if there's distribution that can happen, it should happen first. So in number 8, before we try to combine any like terms, we should distribute. When you have a minus sign, treat this as a negative 3. So we have the 14, and we just rewrite it. Negative 3 times n is negative 3n. Negative 3 times 8 is negative 24. These two are like terms. 14 minus 3 is 11, so that's 11n. And you can write this as plus negative 24, or you can write it as minus 24. They're both the same, so either one is fine. Now 9 is the same. Negative 7b minus 5 times b minus 4. We've got to distribute before we do any combining of like terms. So we again have to treat this like a negative 5. So negative 5 times b is negative 5b. We copy that minus sign down. Negative 5 times 4 is negative 20. Negative 7b minus 5b, we can do keep, change, change. We can also do keep, change, change right here. So that turns that into plus a positive 20. Keep, change, change. So when you're adding numbers that have the same sign together, you add the two numbers, which is 12, and make them negative. Because you add them together and then keep their sign. So our final answer is negative 12b plus 20. Number 10, Omar and Deb each have a digital music player. Deb has 37 more songs on her player than Omar has on his. Write an expression in its simplest form that represents the total number of songs on both players. So here's how I would approach it. Debbie has 37 more songs in her player than Omar. So Debbie has 37 more than Oscar. So the number that Oscar has, because we want to know how many they have put together. So you have to add Oscar's plus Debbie's. Or sorry, it's Omar. I don't know why I read that wrong. Debbie has 37 more than Omar. And we have to add Omar's and Debbie's together to get the total. So I'm going to replace the D with this right here, because I know that the number Debbie has is equal to the number Omar has plus 37. And sorry, this downside of doing an O for Omar, it looks like a 0, so I'll make it like this. For Omar, O-M. So we can combine these two Omars together. Say 2 times Omar plus 37. Or you could have just used X for Omar and said 2X plus 37. Okay, I'm going to show number 11. I know you'll be able to see the answer right away, but we'll talk through it. I don't think it'll be as easy to just verbalize that one. So the table shows the prices of different items in a snack bar. After buying some items, you receive $3.75 in change. If you paid with a $10 bill, which equation could not be used to determine the amount of money you spent? Okay. So let's think about this. Number 11. So you gave them $10. They took away from that the amount of money you spent, which they called in. And the result was that you got your change of $3.75. So that's one way to write the equation. That's one way we could do it. So for the $10 we paid, $10 we gave them, minus the amount of money we paid in, equals our change, which is $3.75. Now we could also, so this is one way, which we'll look at in a second. We could also add the n over to this side and say 10 equals n plus 375. Because the amount of money we spent plus 375, our change, equals the $10 we gave them. So that'd be another way. So let's take those two and look at the answers and see what we get. Okay, so this looks like the second equation I said, n plus 375. They just did the opposite order, but it's the same thing. B looks like the first one I wrote, $10 minus the amount we spent equals 375. That works. Okay, let's go back and see if we can make this one work. 10 minus 375 equals n. Okay, yeah, because if you look at this equation right here, I could just choose to subtract 375 from both sides. That would also work. We could just say the $10 we gave them minus the change they gave us tells us the amount of money we paid. So we've just shown how A, B, and C can work. So D is the one that doesn't, because it doesn't make sense that if you add the amount you spent to the $10, that would make your change. I mean, just look at this. How could 10 plus another positive number ever equal 375? Doesn't make sense. Okay, now we're switching gears to solving equations. I'll refocus, hold on just a second. Okay. A minus a negative 12 equals D. So you've got to remember, anytime you see minus a negative, you need to change it to, there's no one in here so they can't answer, plus a positive. That's because when we're subtracting, we do keep, change, change. So this is really a plus 12 equals, sorry, this is 6, not D. So we subtract 12 from both sides, and 6 minus 12 equals negative 6. I'm not going to focus a whole lot of time on explaining that because you are allowed to use your calculator. So as long as you know how to type in 6 minus 12, you should be good. 13. 6 plus t equals negative 9. So this is a positive 16. I don't care about that plus sign. That's not the point. I look in front of this number. There's no negative sign in front of it, so I have to assume it's a positive 16. So we subtract 16 from both sides. Negative 9 minus 16 is negative 25. G plus negative 18 equals negative 36. So that's a negative 18. So to get rid of it or to cancel it out, we have to add 18. Don't worry about this sign. Just look at the one directly in front of the number. It's a negative, so the opposite is adding. So you add 18 to both sides. We get G equals negative 18. We have negative b minus 15 equals negative 21. So our first step would be to add the 15 over, because it's subtracting, so we do the opposite, we add. That gives us negative b equals negative 6. So one way you could solve this is just think logically. If a negative b equals negative 6, then a positive b must equal a positive 6. But if you want to do it more mathematically, you remember that there's an understood 1 in front of that b, so it's really negative 1 times b. So to do the opposite, we divide by negative 1. That cancels out the negatives on that side, and on that side, giving us b equals 6. 16. M plus 3.75 equals negative 4.15. If I give you one like this on the test, you just have to know the process because it's calculator active. So we'll subtract 3.75 from both sides, and we get m equals negative 7.9. Okay, 17. 7 minus 9. 7 over 9 minus d equals, sorry, I don't know why I keep mixing up 6's and d's. That's interesting. Equals 1/3. Okay, I may give you one with some decimals. I don't think I'll give you one like this with fractions, but since it's calculator active, we'll just roll with it for the moment. We'll subtract 7/9 because that's a positive 7/9. So the opposite is subtract. So we get negative d equals 1/3 minus 7/9 is negative 4/9. And the way you can do that is you can say, I can convert this to ninths by multiplying top and bottom by 3. So 3/9 minus 7/9, 3 minus 7 is negative 4. And then just like we said before, there's an understood 1 here, so you can divide both sides by negative 1, and we get d equals 4 over 9. But again, I don't plan to give one like number 17 on the test. Okay, number 18, we're switching to two-step equations now. Oh, no we're not. Sorry, we'll get there soon. These are still one-step equations, but it was adding and subtracting we did on 12 through 17. It'll be multiplying and dividing we'll do in these next ones. Now, just to let you know on your test, these will be all mixed up. You'll have to know what to do just by looking at it, because we always do the opposite of what they're doing. They're dividing by 13, so we'll multiply by 13. Number 19, negative 75t equals 300. So they're multiplying t by negative 75. So our solution will come by dividing by negative 75. Gives us t equals negative 4. Okay. 20, negative 8t equals negative 72. They're multiplying t by negative 8, so we do the opposite. We divide by negative 8. That gives us t equals positive 9. Because when the signs are the same, when you're multiplying or dividing, the result is positive. When the signs are different, like they were in 19, the answer is negative. When the signs are the same, the answer is positive. We have c over 3 equals negative 42. So they are dividing the c, they're dividing the variable by 3, so we do the opposite and multiply the variable by 3. Negative 42 times 3 is negative 126. M over negative 12 equals 3 over 5. Now there's a few different ways you could do this. You could just multiply both sides by negative 12. That works out just fine. Or you could cross multiply. I'll just do the multiply by negative 12. So since m is being divided by negative 12, we want to do the opposite and multiply both sides by negative 12. So here, the negative 12's just cancel, leaving the m by itself. Here, we treat this as negative 12 over 1. 3 times negative 12 is negative 36. 5 times 1 is 5. And you can leave the answer that way, or if you want to change it to a mixed number, you can. 5 goes into 36 7 times with 1 left over. So both of those forms are equally good. 23.4d equals 3.6. They're multiplying d by 0.4, so we will divide d by 0.4. And you might think this is the one you'd have to use your calculator for, and you certainly can. You're allowed to. But you can look at this instead of a 3.6 over 0.4. Just move the decimal over on both of them. It's really just 36 divided by 4, which is 9. Okay, our last section is two-step equations, starting with 28. 16 plus 5w equals 31. So this is one with no division at all. There's nothing being divided. So our first step is either add or subtract. So that means we look at the 16. It's a positive 16, so we need to subtract it to get rid of it. So that cancels out the 16 there. 31 minus 16 is 15. And our second step is to divide, because we want to do the opposite of what they're doing. They're multiplying w by 5, so we'll divide that by 5. And 15 divided by 5 is 3. And if I'm going too fast anytime, feel free to pause. 29 is 28 equals 4g minus 4. So there's no division here. So our first step is to add the 4 to both sides. And our second step is to divide. 32 divided by 4 is 8. Okay, number 30. 211 minus k over 3 equals 111. So this is one that divides just a single term. When there's division in just a single term, we still add or subtract first, but our second thing to do is to multiply. So we'll first subtract 211 from both sides. The reason I'm subtracting is because I ignore this. This has nothing to do with the 211. It's a positive 211, so to cancel out, get rid of it, I have to subtract 211. So k over negative 3. Remember, you can put the negative up with the k, out to the side, or down with the 3. It doesn't matter. Negative 100. And then they're dividing by negative 3, so we'll multiply both sides by negative 3. They cancel out here. Negative 100 times negative 3 is positive 300. So when the signs are the same, the answer is positive. Okay, I'm going to make up a different one for 31. Let's see, I'll do this. Because this was the third kind we saw. This is one where the whole side is a fraction. The entire side is being divided. When that's the case, your first step is not to add or subtract. Your first step is to multiply so you can get rid of that denominator. So we want to multiply by whatever we have in the denominator, because that is what will cancel it out. 8 times 4 is 32. And then we will add or subtract, in this case add. So it's minus the 7, so we do the opposite and add 7. We get k equals 39. Now, for those of you who are curious, I'm not going to work it out, but the 31 in the book, the answer is 0.75. So if you want to know if you did it right, that's the answer to the one written in the book. Study well, make sure you do some practice, and you'll do great.